Two wires side by side, current flowing free, electricity moving in perfect harmony. But forces in the air, invisible to see, magnetic fields appear.
So this is the setup for today. So we have here the lab manual, then the power supply, and we have the current loops. We have 6 different ones. Then we have the Pasco basic current balance with a 5 ampere maximum. Then we have its magnet assembly, okay, and it has some permanent magnets inside. And this is the balance accessory, the current balance accessory, and this is its own magnet assembly. This is the scale to weight, and 2 banana cables and the metal stand. So now let's do the setup for today. So first, we need to connect the current balance to this metal stand. So you'll put it inside like this, and basically we will tighten it. Then we will get our scale, and we will put the magnet assembly on the scale, this magnet assembly. But first we need to put the magnets inside, as you can see. And you should keep the polarity for this magnet. Basically, the white beside the white. There's one more, the last piece. So right now we kept the polarity, all the white side the same, all the red the same. Then we put the magnet assembly on the top of the scale itself. Then here we start on, and basically it's going to be having a 0 value. We will get one of the current loops that we have. So we have these current loops. Each current loop, it has specific number. For example, this is SF38, and this number you can search for it. You write on Google, for example, current loop SF38, and it will give you the exact length of this horizontal line. Okay, so this one doesn't have on the other side, just on one side. So this number represents the length of the horizontal line or wire. Then basically we connect this one here like this. So it's connected. Then from here you connect the power supply using a banana cable. So we put it like this, and the other side like this. Then we connect these two, the current or the voltage power supply. So we connected the power supply. Then we have to lower this loop to basically go inside without touching the magnet, like this, for example. Without the current loop to touch the magnet like this, but going inside without touching the magnet. Then we tighten it. Okay, then I will do this setup for now. Try to make the metal line inside the magnet to have a better response without touching anything inside the magnet assembly. Then basically we turn on the scale again because we turn it off. Then it's 0. Then we turn on the power supply and we adjust, starting with a current of 0.5. 0.5 ampere, and from here we are going to start to increase, and we will see how much force or what is the weight of this assembly. Basically, the current loop is going to produce magnetic field from this current. This magnetic field is going to exert some force on the magnet assembly, so the magnet assembly is going to be heavier, and the scale is going to give me some weight due to the force of this current loop on the magnet assembly itself to push it down. Okay, try to make this one positive. If it is not positive scaling, meaning that the weight is increasing, basically take out the magnet assembly and flip it like this. Just flip the polarity.
When currents run the same, they pull each other near.